cool. I think we're good to go. Right. So this is intro to Docker. As usual, if anyone has any questions, feel free to drop them in the chat. I killed my compositor, and that fixed the darkness, but it has rendered this black bar. I think we're just gonna have to live with the black bar.
Yeah,
it's not really blocking anything, so okay. Intro to Docker. I'll just pull this up. Okay, so you can't, if you couldn't tell, I'm a little underprepared. I don't really have any slides, but I have a repo here of all the stuff that we're going to do. So if you want to follow along, I'll drop this in the chat. That's a GitHub repo with all the bits. So first of all, I guess, what is Docker? Well, I'm sure you've probably heard of Docker before, and I'm sure you've heard of containers before. So Docker is a containerization system or framework, I guess. So basically what it allows you to do is sort of create a lightweight VM. So if you're familiar with virtual machines, the idea is, you can have one server and host, allocate a certain amount of resources to a virtual machine, which runs its own operating system that's completely isolated and separate from the host, which is useful for many reasons. First of all, security. You can isolate different applications from each other. You can run an application in a VM and isolate it from other applications. It makes things a bit more portable. You could provide like a virtual machine image and then just run that. You can run like a Windows virtual machine on top of Linux or something like that. Containerization is very different in terms of technology, but the interface is somewhat similar. So, or the idea is somewhat similar. You're isolating containers from one another. The difference is with a container when compared to a VM, that you're not actually hosting a whole other operating system. You're not virtualizing the whole operating system. You're using an operating system like Linux, which has features to isolate programs from each other. So it appears when you're inside the container that you can only see what's going on in your container, and you can only talk to things over the network that are in your containers or explicitly allowed. And obviously, again, that's very convenient for security. And the big advantage with containers is they're very lightweight. So with a VM, you have to host a whole other kernel, which is the core part of the system that keeps control of everything. But it's like if you're already running a kernel on the host, all you need to do is run your applications, right? So just isolate those in a container instead of a full virtual machine. There's less resource overhead. The start time is much quicker. It's little more than just starting a new program. So you have to allocate a few different resources and things, but it's a lot less overhead than with a full virtual machine. So that's the key advantage, I suppose, over a virtual machine. And then with that kind of rapid deployment of containers, you get almost all the features of a virtual machine. You can't run other operating systems on top of containers, not really, anyway. And the isolation isn't quite as strong, but one of the big things with a container is its portability. So I can write an application and package it up into a container, and then you can just pull the container, and no matter what system you're on, if you have Docker, you can just run it. And the Docker kind of adds on top of the base containerization system that, say, Linux or some other systems have similar containerization. I believe even Windows has some sort of containerization now. You get with that, you just get like a system containerization, like with Windows, right? So or any other system, you have like a full system and you have a whole image and it's just this big disk. It's like you're taking a hard drive, uploading it to the internet, and then someone else is downloading that. Um, and there's not really any tooling, to build that up. Well, I mean, there's a little bit, but it's not very intuitive or easy to use. And Docker takes advantage of the fact that containers are much easier to spin up, and it has this whole framework for building application containers. So you start with some sort of basic system, and then you layer. Docker has this concept of layers. You layer on top each bit of your application in a kind of a build process, and then you're left with the final container that you can publish online. And then it's really easy with the Docker tooling to download the container and run it. So I suppose what we'll do is look at probably the most important part of Docker, or for writing your own applications that use it, the Docker file. So a Docker file is, I mean, if you look at the way it's written, it's the same format as Makefile. So it's that Docker file is what has the instructions on how to build your container's image. So the image is like, uh, this is the preset, you know, files and application that I have in the container, and then the container is created from that image, and the files inside the container that you create after the container is running are generally like the word would be ephemeral, which means that basically when the container goes away, those files go away. So they're a bit like read-only or temporary storage. You have obviously you need to store stuff like database data, so you have a specific concept in Docker called a volume to solve that problem. But generally, files inside the container only live for the same lifetime of the container. So to build up the application, you write a Docker file, as I was saying. So if you go to just part one, so I've got this repo here, and I'm gonna assume that you have Docker installed. It's pretty straightforward, I think. So again, because it's Docker, uh, once you have Docker, no matter what system you're on, it's the same thing. So I believe on Windows and Mac, it runs it in a VM or something like that. Um, but if you just look up Docker installation, it's pretty straightforward. So yeah, so I've got Docker pre-installed. You'll need, I think I mentioned it here, Docker and Docker Compose. So for the first two parts, you only need Docker. So what we'll just do is run the first command that you need, which is docker build. And this is what takes your Docker file and translates it into the final image that you'll run. So if I do docker build dot, which means basically build a Docker image from the current directory. And so that'll look for the Docker file in the current directory up here. And so if I do that, you see that actually completed very quickly. And I'll come back to why that happened. So if you look at the Docker file here, this is what it just, you can see it has each of the instructions there. And the top instruction is from, and it's basically, so take, when you start out, you typically won't start with just an empty image. You need some basic Linux utilities usually to start with, some libraries and like a shell if you want to check, if there's some problem with your container, you can connect to it. So you use this from to specify, take this image as a base and add things on top of that. So it comes back to this. Oh, Ahmed is coming back. It comes back to the idea of layers. So this Alpine image could have a whole lot of layers, and then we're just layering on top of that. And generally the rule is for each one of these instructions in block caps and pink, you have a new layer. Now Docker will optimize it so that there aren't so many, but usually that's how it works. So the first instruction says take the Alpine image, and then the colon is the version of the image. So you can see I've added just a comment here, the hash. It's not relevant to the actual build, but the image name here, it's called Docker. You'd call it the repository, and then you have the tag or version, depending on what way you want to refer to it. So if I look up Alpine Docker, you'll find usually a link to Docker Hub, and Docker Hub is, yeah, well, it's a bit like GitHub for Docker images. So you can typically find, if you're looking for a particular application in Docker, you can just typically put Docker at the end of it, and you'll probably come up with a link to Docker Hub. So if I go to the page here, minimal Docker image based on Alpine Linux. So Alpine Linux is a Linux distro which you can install on any machine, but it's most typically used to build Docker images. You can see it's got over 1 billion downloads. So the reason everyone uses Alpine is because it's only 5 megabytes, but it has a lot of the Linux tools that you'd be familiar with. So it has a shell, it has all your, your ls. You can install a lot of packages in it, like SSH or any kind of thing that you might need. But it starts off very small, whereas something that you'd be more familiar with, like Ubuntu, is probably much bigger, and at that point you're kind of wasting space. It generally doesn't matter that too much, especially since you're caching images and layers, and Docker will try to be efficient, but it's nice to be able to just have a small image, because typically you won't need the advanced features that Ubuntu might ship with, for example. And you'll see here, typically on a lot of these Docker image pages, you'll have a list of tags, or versions, and multiple tags can refer to the same version. So I've put 3.12, which you can see here, 3.1, 2.1, they're all the same, and latest as well. If you don't put a version, it just means latest. So you can see that's what latest would be. So yeah, that's about it. So the next instruction then, this is where you actually get to building your application. So copy says take something in the current directory where we're building, and so it's like a copy command, and then copy it to somewhere in the container. So slash is the the root directory, but this is the root directory inside the container. And this is where the dot comes in the Docker build. So I have here I'm in part 1, which is this with all these files. Dot is where the what Docker would refer to as the context. So the context is all of the files outside of the container or the image you're building that you're able to access in a Docker file. So dot in a Unix or system refers to the current directory. So that's what it means. It means take the current directory and use that as the context, and it'll also look for the Docker file in there as well. So relative to the current directory, we copy hello.sh and we put it in the root. And then this instruction here, cmd, basically means when I start this container, I want you to run this command. So unlike a VM, you typically only will have one program running in a container at a time, and that's generally how you want to keep it, which is another reason why you don't need something like Ubuntu. You can just stick with Alpine. You're not even running any system processes inside because you don't need them. All you need is your program, because Docker handles the setup of the networking and the storage for you. So cmd says I execute this command. So I've got hello.sh in the root. So if I just do /hello.sh, it'll just run it. And it's just a simple script that writes hello world. So now that I've built my image, I can do docker run. And see if I look at actually, first of all, when I build my image, you see it says successfully built, and there's this big long hash, and that basically means the image is untagged, so it has no name. So it's just this big long hash. If I actually want to build it with a name that I can run more easily without having to type out all these numbers, I can do docker build -t. And then typically what you'll do is put your username. So for me, that might be dev. I think the example I give here is i2d as intro to Docker. So i2d/ and then this will be like the application that you're running. So if I was making some application, we'll call it like foo. So dev player 0, that might be my name, and then foo. So that just basically it's a bit like a directory structure, you know, or if you're familiar with a Java package, you know, dev player 0/foo. So that's mine, and then that's the application. And then if I do that, you can see it says successfully tagged dev player 0 foo latest. I didn't specify the tag, so it's just automatically put in latest. So then once that's done, I can do Docker run, and then use the repository that I made before. So I'll actually use dev player 0/foo this time. And then you can see it said hello world. So now it doesn't, this seems like obviously a very contrived way to just echo hello world, but it becomes much more useful later on to do things with Docker. So I think I mentioned before that you can see that this happened very quickly. And the reason this happened very quickly is you can see here it said using cache. So another really cool thing about Docker is if a file using a copy statement hasn't changed since the last time you built the image, Docker already has that step done. So Docker actually didn't do anything here because these steps are all it knew that hello.sh didn't change, and so it skipped. Well, it already has the Alpine image downloaded. Didn't need to do anything there. Copied hello.sh didn't change, so just use the cache, and then this part was already done. Setting the command didn't change. So if I was to, I'm just going to delete the image. To worry about this, or actually what I'll do is I'll just make a change to the script. So do that, and then I'll tag it i2d/part1 this time. So you can see this time it actually completed both those steps. The cache is done, and it took a bit longer. Yes, 32 threads. High performance Docker container building. So let me see. I think that is about it. Oh yeah. So I would highly recommend you look at the Docker file reference. So this explains the meaning of all the different. I think it's not showing on the right because my screen's too small. Yeah, here we go. So you can see it has all the instructions that you can use here and what they do. So one that's interesting, you notice in the Docker file, I have CMD with square brackets. And if you go here, you can see there are two different forms. There's this one and there's this one, the shell form. So these are not actually, they don't actually do quite the same thing. Generally, you want to stick with this one because CMD means executed in a shell, and that means you're having two processes, and there's problems with when you stop the container, it goes to the shell instead of the process, and it's just you're better off using this. This means run my command with these arguments, and that's it. No subshell messing or anything like that. And that's about it for the moment. So I think we can move on to part 2 now. So we'll actually start containerizing an application. So let me just close all these and change into part 2. So in part 2, see, I may as well open this over here. We're actually going to look at, I've built a really simple JavaScript app, Node.js app with Express. So basically it just, when you access it, it just tells you you're the nth visitor and then increases it so that next time you make a request, it's a bigger number. So I have all the JavaScript tools installed, so I'm just going to use Yarn to run this normally, so without Docker first. So there it's running, and then if I open a new terminal, I can curl localhost 3000. It is visitor 1, 2, 3. There you go. So I'll just stop that. So now we want to Dockerize this. So this depends on the person. If someone was to download your code, this depends on them having the right version of Node.js. So you might be using some new or old feature depending. It depends on them having the correct tools, like Yarn I'm using in this case. So Docker can allow you to get rid of all that fuss, because you can specify, I want, the LTS, the current LTS version of Node. So if I look up Node.js Docker, I'll find the Docker page, and you can see here this huge kind of matrix of versions that they support. So like I think 15 is the latest release, 14 is the LTS release. So if you look here, yeah, latest is I think it's just Debian Node.js. So I've added Alpine because I'd prefer to use the Alpine version. You see here, yeah, so LTS Alpine refers to this, which is 14.15.0, that's Node.js version, and then Alpine 3.1.1. So if you wanted to lock down to a specific version, so let's say 14-Alpine. So now I want to make sure I'm using Node.js 14. And then anyone who runs this, it'll always be Node.js 14 because that's the image. Okay, so we have a new instruction here, work dir, that basically says inside the container, we're going to be in this directory. So typically, I think by default it's just /, so the root. But I want to put this in a folder somewhere, so I'm going to put it in opt app. So now when I copy package.json and yarn.lock / that basically means copy into the working directory, which we set here to /opt/app. And now we have an interesting instruction, yarn install. So this allows you, or run, and what we're running is yarn install. So run basically allows you to run things inside the container that you're building. So what'll happen is this will be run in a shell. So you can use shell things like and, for example, if you want to do multiple things at once. Oops. What happened there? So yeah, so this will install all the packages in the current directory inside the container. But this will, once the container is built, this is all done, and the dependencies are pre-installed. So then once the packages are installed, which is a step that you'd normally do, by hand when you download the code, you copy the source file in, and you'll notice I'm doing these things in a particular order, and I'll come back to that. And then expose here, that basically it doesn't actually do anything. It's more like an informational thing. So basically it says that I'm running on something on port 3000 inside the container. It doesn't actually do anything. It's just more of an informational thing, so you can list the images. I think if I look at I can't remember exactly where it shows up, but I think if the container is running, it'll show that there's supposed to be something on this port. And this time I have an argument to my command. So I'm node, obviously, and then server.js. So if I build this, the -t. So it's going to download the image. It's actually again being smart and has used the cache. See if I can get it to. Well, what I'll do is I'll change something here. So let's put that, change that to a 0. That should work. Actually, that might break something. I'll just add a space there. That should do the job. So now you'll see it's copying this and it's doing the run step. So then what you'll notice is that it only did the yarn install after once I made a change to the package.json, so my dependencies, right? So that means that Docker can allow you to avoid that build step every time. So you'll see that server.js is copied in after this happens. So basically, if I change something in package.json, the cache from this step and all beyond there is invalid. All the steps have to be done again. But if I make a change just to the server.js, so let's say I change this and add extra exclamation marks, then I can Docker build, and you see it skipped past the yarn install because the package.json didn't change. So only the server.js changed, and therefore it only had to repeat this step and the ones after that. So that's why you would want to separate out this copy from this copy, because that way you can avoid having to reinstall all your dependencies, which if you have a big Node.js project, there could be that could take quite a long time to install. So now that we have that, we can run it. So we can just run it again. Now, what I've got to, actually, something I missed from the first part. If you want to see the containers that are currently running, you can do docker ps. So I just have some other random containers running here. But if I do docker ps-a, this means show all the containers, not just the ones that are running, but the ones that aren't running. So you'll see on the right there, it says status exited. So if I do docker run, it will actually run the container, and then it'll stay behind in the background. So it's actually still there. So that was just a demo, and I don't really need it. So you can restart containers once they're stopped, and they will retain whatever files they had. Generally, you want to avoid that. So to delete the container, so again, docker ps-a to list all the containers, including the ones that aren't running. And then docker orm is to delete a container, and you put in the name. It's a bit hard to see here because it's quite wide, but you can see it's container ID, blah, 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 ports, names. So the name of this container, if you don't provide one, it just picks a default one, which is random. So loving pike here, it's picked. So I'll just docker orm loving pike, and you can see it's gone there now. So if I was to keep running and running and running, it would create more and more containers, which they don't take up much space or resources, but they do take up a bit. So you don't want to keep those around. And to avoid having them staying around, what you can do is add --orm to your Docker run. And that basically means when the container is finished, just delete it automatically. So I'm going to do that in this case. And I'm also going to add -i, and -i stands for interactive, which means basically keep the process in the foreground. So normally when you run Docker, it will like send it into the background, and you won't be able to see what's going on, especially if you're console.logging. So I'm going to add -i there. So I'll do i2d -part 2 /part 2, and so now if I do that, see server running. So right, our app is listening on port 3000. I'll just use curl on that. You see now we have a problem, right? Connection refused. It's running on port 3000, right? Well, it's running on port 3000 inside the container, which is not the same as port 3000 on the machine because it's a totally separate network setup. So what I need to do is create a port forward or a port mapping. And the way you do that is by adding another command line switch, and that is port. I think it's dash port, but -p is shorter. So I'll do 3000. So this is the port on your computer, so your machine, and then you add a colon, which is to separate these two. So you're basically saying I map port 3000 on my computer to port 3000 inside the container. So if I do that, same thing, but this time if I curl localhost 3000, there we go. See, we've got the UI is working, or the server is working now. And if you wanted to, you could change this mapping. So you could make it, 1337, let's say, 1377. 3000 doesn't work again. 1377. There we go. And so if I actually look up, Another reference page for you is Docker run. So you can see what all these different things do. So if I look at the dash dash port, there's a huge number of different things you can do. But I'm going to come up with, or I'm not going to come up with, I'm going to show you an easier way than adding all these endless command line switches here in the third part. Yeah, I'm not exactly sure where it is there, but it's in there somewhere. So, right, so we have this cool web application running, right? But there's a problem. If I run the container again, I visitor number 1, visitor number 2, visitor number 3, and then I stop it and run it again. I'm visitor number 1. So it's not saving this, and that's obviously you'd expect that because it's not writing anywhere. It's just keeping it in memory. So we need some sort of persistence. So we're going to add a sort of a database. Not really a database, but sort of. Redis is what we're going to use if you're familiar. It's in memory, but it has an option to save to disk. Let's see. I think that's about it for this part. So if I go into part 3. Now this is where we're going to introduce Docker Compose. And Docker Compose, if Docker brings the containerization tools, Docker Compose really allows you to, in a clean way, run your Docker apps and multiple Docker containers together. So we add another file, the docker compose.yaml. So I'm going to pull up the compose reference here. So at its simplest, a Docker compose file is a bit like a shortcut for writing all of these flags into Docker run, but it's kind of a bit more powerful than that. So this time, if we look at my JavaScript, I've added some more stuff. I'm using Redis here. And then basically what I'm doing is, if you're familiar with Redis, I'm using inc, which basically just increments a number and then gets the value after the increment. So this will basically do the same thing as before, but using Redis. So we'll get persistence. So in a normal system, what you might do is, deploy Debian, let's say, and then you'll install Redis and you'll install the application, and there it is, it's deployed. But then, you have to go through all those steps to set everything up. With Docker, you could run both at the same time, but you probably shouldn't. You should probably have a separate container. So if we look at the Docker Compose version at the top, this is just a YAML file if you're familiar with YAML. And if I look at here's the compose reference. So there are various versions of the compose file format, and they match up with versions of Docker Engine. And so you'll see here certain features added in a specific version. But typically you can just go with version 3. And if it tells you that it's not supported or is too old, just increase the version to whatever that is. You're probably running the latest version of Docker anyway. So services, then each entry here under services corresponds to a single container, and there's a name for each one. So first I have our database, and that's Redis. And again, if we look at Redis Docker, you can see there's a whole, well, it's not that big, but there's a matrix of tags, and I'm going with Redis 6 on Alpine. So that's looks like it's 6.0.9 on Alpine 3.1.2. And command. So in the Docker file, we have this CMD, which specifies what the command is. You can override that with Docker run or indeed a Docker file. So I'm adding something. I'll come back to why that's here. Volumes, I'll come back to that. So this is our app. So we have the image, which we're going to call I2D part 3, and build dot. So this is like when we had our Docker build. See here. We have the dot, and the -t is like the image part here. And ports, that's like when we have the Docker run when we do this. You can see it matches up quite well. And obviously it's an array, so you can map multiple ports. And so in order to run this application, well, I suppose let's talk about the database, right? So we have this command. And if you scroll further down on the page here, you can see start with persistent storage. And we have Redis server append only yes. So command in a lot of, so there's also, if you look at the Docker file reference, there's another thing called entry point. And it's kind of confusing. I would have preferred probably if they picked a different way of describing it, but entry point and command are slightly different. You can override both of them, but generally you'll only override command or set command at runtime. So you can use it to add extra switches or whatever to the internal process, and that's what they're doing here. So I don't have to actually put in Redis server the way they've set it up. I can just add -- append only yes, which enables persistent storage in Redis. By default with Redis, it's all in memory. Nothing gets saved to disk. Just to keep things simple, I will actually add Redis server here. So Redis server is the command to start Redis, the server. So we're overriding in essence this CMD that's in the Docker file at runtime. So volumes are how you do persistent storage in Docker. So basically what this means is it's a bit like the port mapping. So you take a directory on the host and you bring it inside the container at this directory. So if you're familiar with mounting on Linux, it's what they call a bind mount, where you take a directory and you attach it somewhere else. So if you look at the other place, it's exactly the same as the original directory that you bind mounted. So the / just means, again, within the current context. So this is the directory here, data. And then I have the mapping, and it's to / data inside the container. So again, the container has a totally different set of files than the host. But because it's a container, we can do things like bringing specific directories in. So basically this means, again, because the container's file system is only exists for the lifetime of the container, this allows us to kind of get around that, sort of, to store actual data outside the container. And so you can see here, persistent storage, you add a volume. So this -v here is like -p. So this is the host directory, and we're mounting it to /data. So inside the container, Redis will save things in /data. So now I think we're pretty much ready to go. So if I do docker compose up, and then I'm going to actually add -- build. So docker compose up basically gets docker compose to start all the containers in your docker compose file, and it runs in the foreground. So it's a bit like adding -i as well. And -- build basically tells docker compose to do the docker build first. So it's much more convenient. You just run one command and it does everything, and it starts all the containers at once. So if I do that, everything's cached, so it went by immediately, and it's not building. We're not building Redis. It's we don't have the build part in here, so it's just pulling it from Docker Hub. And then you can see here at the beginning, you can tell that this is coming from the DB container and this is coming from the app container. So now if I open a new terminal, actually what I'm going to do first is delete. I had some data from earlier, so I'm just going to get rid of that. And then if I localhost 3000, visitor 1, 2, 3, so that's what we expect, right? And if I stop that and start it up again, Now it's actually keeping track. So if I look at the data directory, this is just the format that um, Redis likes to. One of the ways you can store things in Redis, it's kind of like a chat log of the commands that were sent to it, and it just replays it on startup. So every time I do this, the file goes longer, so you can see each of the increment commands there. And then obviously when I stop the container, this file is not in, it's not within the container's file system, it's brought in, it's mounted. This file still exists when the containers are gone. And then when I bring it back, Redis loads everything in and we keep going. So there you can see the persistence at work. Let me see. I think those are all the main details. I think I listed in the README for part 3 some extra handy commands. Again, the Docker Compose file reference is very handy. But if I want to just build it, so I want to do just the Docker build part, but with Docker Compose for all the containers, I could do Docker Compose build. So it built both. It only built one because again we're using Redis from Docker Hub, and if I just want to run it, I just have to get rid of the dash dash build, and then if I want to get rid of all the containers, I can do Docker Compose down. So the containers, they don't get deleted by default, but Docker Compose down will get rid of them. And if you want to have them run in the background, so like you're not adding the -i in Docker run, you can do Docker Compose up -d. So it creates the containers. Now they're running in the background. So it's still going. And then if I want to, again, stop and get rid of those, I can do Docker Compose down, and that'll get rid of them in the background. And something else that can be handy if you want to have things automatically start when the Docker server or daemon starts, then you can add restart always. So basically then when you reboot your machine, the containers will come right back up. So I'll just put that here and here, up -d, so in the background. What I'll do is I'll stop Docker. So that's gonna stop everything in the background, and then so it's connection refused. And then if I start Docker again, you can see it's already running because I added this to start always. The way this kind of thing works, again, if you look at the compose file reference, restart, not restart policy, that's a different thing. Here we go. No is the default restart policy and does not restart a container, blah, blah, blah. When always is specified, the container always restarts. So that's not very clear, but if you look at this, it'll bring you to the Docker run or Docker containers automatically. Yeah, so it's a dedicated page. So always is manually start. I think it doesn't, it still doesn't say here, but basically when Docker starts, it will start the container. But I would only use this if you definitely want the container to start. Otherwise, you'll have a whole load of containers starting in every time you start your machine. So I think that is about it. That's all I had planned anyway. We're actually pretty much perfect timing. But if anyone has any questions, I'm happy to explain. And is threading any different? So you mean just like starting a thread, spawning a thread in Python or C or whatever? Nope. So it's it's just like you start a thread and it'll run on a different core. By default, it will have access to your whole CPU, so it could hog the whole thing. But if you look at, I think it's, what is it? Limits, CPU, resources. Here we go. This might only be in, hold on, let me see, deploy resources. Okay, so you can't actually specify resource limits on containers running just in plain Docker. You can do Docker Swarm, which is a little bit like, if you know Kubernetes. Docker Swarm is kind of like Kubernetes Lite specifically for Docker. In Kubernetes, a big thing is I can limit a container. So Kubernetes is for deploying huge loads of containers at scale. So Docker is kind of a part of that. But Kubernetes, you wouldn't use Docker Compose. You'd use a Docker file to build your container. And then at runtime, you'd use some Kubernetes stuff. So we might do a Kubernetes event or series, because there's quite a lot to Kubernetes. But in your Kubernetes description, you would typically say, I want to limit to 50%. So this is measured in cores, basically. So this basically means you can use up to half a core, and you can use up to this amount of memory. And in that case, it's not directly related to threading, I suppose, but you could only use that much of a core, half a core, or you could use 3 cores, we'll say. But by default, there are no limits, and it can just use whatever it wants. There are also ways, by default, there is no disk limit either. Again, that's obviously more relevant, particularly if you're deploying things at scale with Kubernetes. There are ways to limit disk usage in Docker, but it's generally not done, because Docker, when you're running things in Docker, it's usually just for development. So Docker Compose can get you, Docker and Docker Compose can really only get you so far. If you're just deploying something on your home server, it's fine. But if it's something that you actually need, to run in production with security, then you're obviously going to want to apply limits and disk limits on your volumes.
Hi, Jack. Quick question for you there.
Sure, fire ahead.
And I'm guessing the answer is it depends. But would you find yourself, if you're deploying an application with a database, would you tend to compose that into a single Docker image, or would you run separate Docker images for a database and your application?
Um, so I think I briefly mentioned this earlier, but generally, if you have two different programs, two different processes, you should almost always be running them in separate containers. There might be some specific cases where you don't, but particularly if they're two different applications and not two parts of the same application, you would use a separate container. Because the whole ecosystem is kind of built that way as well. Like, you have this pre-built Redis image that you can just drop in here. You don't have to install anything. Like, I don't have to use, apt-get to install Redis. I
Yeah.
just use this image, and then I have the two containers. And actually, something I glossed over. You can see here I have this DB and this app. If I go to my server.js, the address I've put in here is just DB. So that's normally where you'd have like an IP address or a
Okay.
host name. But Docker will automatically wire up the DNS so that DB points to uh, the Redis container that I have here.
Very good. Okay. Cool. Cool. Thank you.
No problem. Um, but yeah, I think if there aren't any questions, we'll probably finish up. I don't know. I'm not sure if I mentioned this earlier, but this recording should be going up on YouTube, and obviously this GitHub repo is available just on my GitHub. So yeah, thanks for coming.